Good morning, everybody. I'm presenting today on interactivity and multimedia mathematics, and I recommend, if you've not done so already, to go to Tools and Audio Settings, and then Audio Setup Wizard to make sure that you can hear me. And if you are wondering why there's no noise at all in this room, that's probably, you probably need to work on that. I guess I'm going to get started. We have a map here. You can see there's people from all over the world, which is, I think, terrific. I'm going to move forward to my first slide. Okay, well, we've had some extra slides dumped in here. Okay, so my name is David Weiss, and I currently am teaching in Vancouver, British Columbia. I've been teaching mathematics for 10 years. So this is my 10th year coming up, actually. And I started my teaching in New York City, and then I taught for 3 years in New York City, and then 2 years in London, England, 2 years in Bangkok, Thailand, and now I've done the last 2 years in Vancouver, Canada. And I'll be I'm moving into a new role. I'm going to be a learning specialist for technology, but I'm still teaching one math class. And what I want to talk about today I'm going to start with sort of the why you would want to do interactivity and multimedia in the math class, and then I'll move into some ways you can do it, sort of some of the how. I've left my contact information up there, as well as a link to this presentation, so you can download it later. And if you want to contact me, Twitter, or there's a contact link on my blog. Those are both good ways to get in touch with me later after this presentation. Okay, so I'm going to get started here. So my first thought is that we have this is a formula I've created to talk about what's going on currently in mathematics education. And basically, we have a population that's been exposed to a bad curriculum for multiple generations. And the result of that is basically a functionally enumerate population, where a very tiny percentage of the population actually uses any of the mathematics that they do on a regular basis. So I'll show you an example of that. This is a slide. This slide is taken from the Canadian Council on Learning, and the slide is representing the levels of numeracy for various people, for adults, basically, over the age of 16. And the parts that are green are the parts where there is people who are considered where basically at least 60% of the population is considered functionally numerate. And the parts that are anything other than green, yellow, orange, red means that there is at least 40% of the population or above which is not numerate. So you can see that the vast majority of Canada is from this is functionally enumerate. In other words, they don't know how to use mathematics in any sort of sensible way in their lives. And the fault of that, I think, has to go back to the education system. One of the issues that we have is that we teach people how to do this very, very rigid school mathematics, and we don't do a lot of focus on context mathematics. So we don't do enough. How do we put this mathematics in context? And now, another important thing about this is Canada is ranked very, very high in the world in terms of mathematical computations according to the international tests. So if your country is ranked lower than Canada in this issue, then your math looks very similar to this one, or is even worse. So the basic, what we do right now in terms of building curriculums, we sort of start with a list of mathematical computations we want people to know. So we say, okay, well, we want people to be able to do calculus. So what do they need to know to be able to do calculus when they graduate from high school? And so we work backwards all the way back to first grade to make sure that the people are able to do calculus. And Joe's got a good question. What exactly does enumerate mean? The Canadian Council on Learning has a definition for numeracy that's used for that map. If you come to you go to the web page, you can see how they define it, and it's a pretty good definition. But it's basically like DW is saying, it's related to literacy, same kind of idea. So this is essentially how we construct math curriculum. We start with the computations, and we go out to problems that are related to those computations, and once in a while, we'll connect those computations to the real world. Right? So that's the basic thought there. Now, here's what I would like to do. It's a bit of a shift. I want to start with the real world in the middle. I want to start with, here are things that are interesting about the world. Here are applications which are cool about the world. And let's focus on relevance first. Then from that relevance piece, we're going to figure out things that are related to number theory. We're going to show that it's related to calculus, related to probability, related to statistics, etc. And one of the consequences of this is that the connection to other subjects is really easy, right? It's really easy to connect to other subjects when you shift your focus from a list of curriculum to cover to sort of a real-world embedding of the curriculum. And so what I want to do is talk about sort of this sort of picture. Mathematics education right now is generally, because of the focus on computation, it's not really relevant to the participants, right? They don't really get why they need to learn this math. And it's not really interesting to them because it's algorithms. Algorithms by themselves are not innately interesting. Very few of them are. Some of them are. And most of them are not very interesting. So what I think we should do is we should make sure that it's relevant to the participants, to the students. It's either relevant to them right now or possibly relevant to them later in life, but some sort of relevance, or it's engaging. I mean, we can do some really interesting math, which isn't totally irrelevant to the real world. Mathpickle.com has got these kids solving these really complex problems which have no application in the world, and that's okay because the problems are interesting. They're worth solving. If it doesn't fit one of those two criterion, I think we don't need to teach it. Now, those are very broad criterion, and I don't think a lot of stuff is excluded, but when you shift your mindset from I have to cover this curriculum to I have to make what I'm doing relevant and engaging, I think it makes a big difference in the overall structure of your math class. So some examples of things which are highly mathematical in nature and very, very interesting. Of course, trees are examples of fractions. The growth rates are examples of exponential functions. We have fractals, which are, you know, you don't walk around every day and see a fractal, but they're really interesting things to participate in. Fractals are mathematics. It's only been around for about 40, 50 years, maybe 60 years, but the basic mathematics is so interesting, so engaging, and not usually taught. I mean, I don't think there are any high school curriculums that say kids will be exposed to fractals, and that's really kind of a shame. The mathematics of the universe, how galaxies are formed, all that kind of stuff, I think that's fascinating as well. Dan Meyer's doing some great stuff where he's showing that you can use multimedia as a way of taking things in the real world and breaking them down to something the kids have the ability to analyze. I think that's really important as well. And I just, I went with my camera and I walk around and I take pictures now of things that are mathematical in nature. And I'm starting a series of stuff that's sort of like, here are a bunch of examples of math in the real world. Let's walk around and look at the world from a mathematical lens and then share that idea with students. So the top left corner, that's probability, right? Take them out to carnival, have them watch some of the carnival games, and notice, boy, people lose a lot. Why are they losing a lot? And you can sort of do observations. The right-hand side, how do we share cake equally? How do we take a piece of cake and decide what the best piece to pick is? All sorts of very interesting mathematics. In the background there, in the bottom left corner, you see the science world. That's in Vancouver. That's a geodesic dome. That's amazingly mathematical, and it's something we built. So real world doesn't necessarily have to mean natural world, but it definitely is something that we've constructed based on mathematics. The picture on the right is kind of interesting. It's just perspective, right? So we're talking about scaling of things that are further in the background or small in appearance, and people will recognize that they're doing mathematics innately all the time. Some great books if you're interested in reading more about this. Joe Bowler has a book called, Jen, can you help me out here? Joe Bowler's book is, I don't have it in front of me, What's Math Got to Do with It? That's a great book. Keith Devlin read everything he's got. It's all amazing. If you're interested more in sort of understanding why this is an issue, I recommend reading Derek Stolp. His book is called Mathematics Miseducation. Very, very good read, particularly for math teachers interested in what's it called, constructivist mathematics. And then we have the book, which really has got me really thinking a lot. Yeah, that's right, Kelly. It's all one word. And the book that's really got me thinking a lot is Paul Lockhart's A Mathematician's Lament. And he would disagree with this real-world mathematics, according to his book. He would say, don't worry about the real world. Focus on stuff that's interesting. The real world will come out of it. And that's a valid point of view as well. Okay, moving on. So this is just the credits, so you can come and look at those pictures. Those aren't all my pictures, so we'll skip that for now. But anyway, I had to have it in there. Okay, Khan Academy. This is possibly a useful tool. I'm going to put possibly there because I'm not sold yet, but it's definitely not an example of what I'm talking about. I'm not talking about kids digesting video as a form of using interactivity and multimedia in math class. So what I mean is, what I mean by this is that just digesting multimedia is not enough. Just participating on websites is not enough. They have to be creators. So instead of Khan Academy, what I would recommend is mathtrain.tv. Let's see if I got that next. No, let's go find it. Just a second, I'll come back in the wrong order. Here we go, mathtrain.tv. This is virtually the same idea as Khan Academy, except there's a really big difference in who the authors of the videos are. These videos are created by the students, right? Much, much different perspective. So while the Khan Academy could be useful as a tool, again, not sold on it yet, it's not what I'm talking about in particular in terms of multimedia and interactivity mathematics. It's not quite there yet. Most important point to make is that the kids can't ask questions, right? It's really hard to sort of, you see all these videos with comments on them and they can't answer any questions. Anyway, I think this might be the future of the textbook, right, rather than the future of the classroom. So here's an example of a really simple thing you can do, which is, I think, automatically embeds what you're doing in the real world. I don't know if this is obvious. The left-hand side is a traditional worksheet. It's exploring, given two coordinates, find the equation of this line. Very, very basic worksheet, bunch of practice. The right-hand side is what I do now. I have kids go and either find or create a picture and find the equations of all the lines in their picture. So the kids basically choose the level of difficulty they want. They figure out very quickly, the more lines, the more work. The second thing which is really interesting about it is that they will finish the picture, right? Whatever picture they choose, they're going to make sure they finish that picture and they figure all of it out. So I had one student, we did this thing where they were creating pictures of robots, and he showed me his robot. He said, this is a really cool robot. I said, yeah, it is, but boy, it's complex. You sure you want to do that? And he said, yeah, I'm going to do it. And this is not a strong student. I want to remember this. This is sort of an average student. He came back to me, and he had found the equation of the lines, the domain, the range, and then drawn, carefully labeling, color coding, everything, with 183 lines in his little robot picture. I wish I had a copy of it still. I'm trying to imagine any student ever finishing a worksheet with 183 equations in it. So he has done exact same work as it would be on the left-hand side, right? But way, way more work than you would normally see somebody doing, a student doing on a worksheet. And the reason why is because he's engaged in what he's doing. He's interested in it. He sees a purpose. This is pretty important. So another simple idea I did with 6th graders, symmetry. Have them take pictures of, or find pictures on Google Images, whatever, of their favorite celebrities. Take the picture, split it down the middle, look at the lines of symmetry. So they flip it back and forth. And what I thought was really interesting about that was that one of the students took his picture and flipped it back and forth. He realized he looked the same, that it didn't matter how he mirrored his face. He always looked the same in that picture. And it was an eye-opener for him, right? It was really interesting. Like, this is the discovery he's made about himself. The other thing is they love taking celebrities and making celebrities look funny. I think it's pretty cool. So it's an interaction between mathematics and culture, which is useful. This is from John Scammell. I mean, this is a very, very typical exercise. The question is there a relationship between the golden ratio and beauty? So you take a person's face, you dissect it into different ratios, and you try to determine, like, does somebody that we consider beautiful actually have the golden ratio present in their face? It's a mathematical computation. It's not something that's terribly complex. The kids have to be able to divide decimals. That's about it. But now they see there's a reason for doing this division. So we have a video here that I'd like to share. I think I'm going to have to do an application share for a second here. So apologize for my Twitter feed showing up. Question, yeah, I've taught in my career from 5th grade up to 12th grade now. Okay, so hang on. Application sharing? No. Okay. Okay, so it's finding running applications. So hopefully that finds out that figures it out quickly. Okay, well, while you're waiting, if you want to, you can just, there we go. If you want to, you can just open up the video itself. It's weiss.it/video1. Okay, so this is a really simple video. Please give me a smiley face when you've seen the video. It's very short, just an idea of something that's really useful. So smiley face if you've seen the video, please. Okay, I'm not seeing any smiley faces, so I'm slightly worried. Okay, hang on. Okay, we got a smiley face. Yay. Just making sure. Okay, so if you didn't see it, it's a video of a ball flying across a screen. Okay, very simple video. The idea here for this video, let me just play it and then pause it. If you look at the ball, you notice that it is really easy for kids to see that you can layer mathematical coordinates on the world, and then you can then take this and analyze and see what shape it is. And we know as mathematicians that shape is going to be a parabola, but I would say don't share that with kids at first. Let them figure it out, and let them try to see if they can come up with an equation of that shape. And then you can talk about applications at the same time. Like, look, we want to know where things fly, right? Like, we actually do want to know where a cannonball is going to fly, or an unguided missile, etc. So this particular exercise, I've tried it a lot of ways. I found that actually videotaping it is the easiest way. I think it's really kind of critical that people see that the kids see that if you try to do it without videotape, what the kids invariably do is they get a peak. Nice little sharp peak when they do it, and the data isn't very good. So I recommend using videotaping for this instead. Share the next video. Okay, so this one here, I don't know if it allows you to hear the audio or not, but I'll just explain the project and pause the video for a second. I've noticed that video is not the only way to capture really useful information. You can also, just with the computer, no webcam, whatever, use the internal mic to capture kind of cool information. So what we did there is we had a ball bouncing, and we bounced it, and we recorded the audio from the bouncing, and then we opened that audio file up in Audacity, and right away the kids can, I mean, if you look at that picture, what you can see, the kids know when the bounce has happened, right? And they can use the tool to, yeah, okay, I'll put them here. So the first video was video 1, and the next one is video 2, etc. So the kids can see the bounces, and then they can go and they use the tool Audacity to record the distances. And what I noticed is that then what they get is a graph of bounce versus time, and it's really accurate, like the data is accurate within, the nearest millisecond practically. And it's otherwise incredibly difficult to do these interesting real-world activities and get reliable data. This is really important, that you can very easily do these and get unreliable, not very useful data. So that's one of the key things about this particular activity. The third activity is okay, so I just want to verify, can you guys hear this audio? Can you guys give a thumbs up if you can hear it when I'm playing the video? Let me know. If not, you can come back to it later, wees.it/video3. Okay, go and check out the video. If you can't hear the video audio, that's fine. This is one of my students. I think you can tell from the way she's moving that she's, anyway, so she's doing a tutorial on linear regression. And she's interested in it, and she's sharing stuff. And she's actually done something quite clever, which is that she's got two variables she's chosen deliberately, which there is no way that there's a nice, perfect line of best fit between the number of pets you have and the number of eyebrows you have. So this is demonstrating that she recognizes, she told us, I'm doing this because it's satire, right? Because I want people to sort of laugh at me at that section because they realize that there should be no relationship between eyebrows and number of pets. So she's doing that kind of for fun. But she's demonstrated a deeper understanding of what regression lines are for, talking about relationships between two variables, and she's quite animated and quite interested in this process. Well, she's also one of the weakest students in that class. And if people can't hear anything at all, please make sure to run the audio setup wizard. If you can't hear me at all, then that's not going to be very interesting. So she's turned from a student who is disengaged and disinterested in math into somebody who is standing up in front of a video camera, willing to share her understanding of something with basically the entire world. And she's aware that I'm going to be sharing this particular video in all of my professional development sessions for a long time to come. And I think that certainly changed her perspective on what she's doing. Okay, I got one more video to share. This one again, I recommend going and seeing this video yourself, the whole video. I'm just going to pause it at one stage here. Okay, so let me jump ahead here for a second. There's a useful picture. Okay, let me find it. Okay, so what these students are done, what these students have done is they've created what I call a video word problem. So they've gone and they've taken a real idea, a problem, a story that they've created, and they've turned it into a mathematical problem. And so they've taken the idea of a written worksheet, sort of word problem from a textbook or something like that, and they've changed it into a narrative. And from the narrative, then you've got to try to figure out what's going on. You've got to try to solve the problem. Now, in their particular problem, they actually share more information that I think is useful. They actually have, I don't have it in this view. They actually shared an entire diagram of the situation, which I think is unnecessary. I think that it's better for these students if they actually don't share too much information. That you actually can have some really good undefined problems or ill-defined problems where the person who's solving the problem has to make some assumptions about what's actually going on to be able to solve the problem. I mean, the basic idea is that these math narratives are related to areas in your curriculum and, more importantly, are problems that, maybe you need a little more work to do than sort of taking three numbers, putting them in an equation, and getting an answer. And most importantly, there isn't one answer. There are lots of different answers for this. Okay, I'm going to try to turn off application sharing and switch back to the other view and forward a few slides ahead. So here's one last example. I've got 4 minutes left. One last example is this cell phone example I did with my students. I started last year. I had no cell phone. So I went to the students and I said, look, I don't have a cell phone plan. Can you help me choose the best cell phone plan out there? And we're going to use mathematics to do it because I'm a math teacher. Like, I'm not going to just sort of haphazardly choose because you think that Rogers is better than TELUS. So the first step, go and research cell phone plans. First thing the kids discovered is that there are hundreds of cell phone plans out there. So they had to limit their search to a particular area. So they decided ahead of time, what are some useful cell phone plans to talk about? Then they graphed their data. They went and they graphed. Now the horizontal lines here are basically the cost of the cell phone plan initially per month, and the lines in an angle here represent the costs of the cell phone plans at after you exhaust your minutes. You have to start paying per minute for the cell phone plan. And this is the first graph the kids produced for me. They show it to me. They say, great, we're done. We've solved it. And so that's good news, right? Because they are trying to use mathematics, and they realize that they don't have something which is a one-number solution. The graph is the solution. And then I looked at it and I said, I can't read this graph. I don't get it. So the kids went next step, and they add a green line to represent the actual optimal solution. So now the solution is not a one number. It's a representation of the solution rather than just a single number solution. And what I found really interesting here was that the kids then, Mr. Weiss, I can see that it meets right here, but I don't know how many minutes that is. And when I'm talking about the solution with you, I need to know how many minutes that is. So I had to show them how to solve it using algebra. So they had to learn how to solve for the intersection of two lines, which, by the way, was not in the curriculum at the time, but the kids could see that that was a necessary thing to be able to answer the question, which is the best cell phone plan. So then after some convincing, I said, keep this as part of your notes, and then give me this version. I mean, this is the version that I can go and then read and say, this is based on the plans you chose, this is what I should do. And how you read this is I go and I say, well, if I'm going to use 300 minutes in a month, I go up the graph and I see that tells me whichever equation is represented tells me which cell phone plan I should be using. Anyway, the idea was that I got to take all of these various areas of mathematics and embed them in this one question, which is the best cell phone plan. They had to know how to plot graphs, they had to know how to create lines, they had to know how to choose scale, they had to know how to solve for the intersection of two lines. They had to understand that when the line is at a different slope than another line, that is a relationship to the cost. And I think that this allows students to see that linear functions are something which describe the world rather than being something sort of like external magic, why are we doing this sort of thing. Anyway, that's basically all of the ideas, but I have one last statement, is that if we had a population times a purposeful curriculum, I think with only one generation, we'd actually have some hope for our mathematical future. So thank you very much. Here's the contact information again, and I'd love to hear if anybody has any questions or things they'd like to share. And if you want to, you can raise your hand if you want to speak your question, or you can just type it into the window.
Thank you so much, David. Let's go ahead and give David another round of applause. And as he said, if you've got a question, go ahead and use that little hand underneath the participant window.
That's great. That's great.
And you can raise
so let me know if you have any questions. We'll give it a couple minutes. Maybe we can also share the links to the other presentations now. Do you want to go ahead and do that?
Yeah, I'll go ahead and share links.
So easy way to contact me is at David Weiss on Twitter. I'll give you my email address as well. If you have any questions about what this looks like in more detail, I'm happy to share it. And also, please check out the Real Math hashtag, which we're using to keep track of other math problems, right? And as Barbara says, you can totally do this with younger kids too. I mean, check out the Real Math hashtag. There's a whole bunch of ideas of things you can do with kindergartners and making math more interesting and engaging, because really, we've got to start young. No reason to start late.